pulley system as per is a metallic or a wooden disc with a groove rim, okay, and a string or a rope is passed through around the groove at the rim, and the disc rotates about an axle passing through the center. You all keep your video off. I will start my videos. Okay. And then we'll be trying to see. I hope all of you are able to see me. You can just put Y in the chat box. Today there is no chat box available. I got something which has been attached. Now to show you a pulley, I'm taking a small pulley I have made. Okay. Now when we say that it is a metallic or a wooden disc, it can be made up of plastic also of various size. So when you try to see, if you try to see, you will be able to see this is a wheel sort of thing. This is what is called as pulley. It has got a groove. If you see it in the center part, you will find that there is a groove. Now, this has been attached to an axle from a center about which it can rotate. If you see, this is going to rotate. I have made a prototype of a pulley. It's not exactly a pulley, okay, but yes, it will be acting as a pulley. Whatever application of pulley we are able to do it. Now this is your pulley. If you see, so the main part is your frame. This part is considered as a frame. This is considered as a disc, okay. This is your disc, this is the frame, okay. This is the axle, the center about which it is going to rotate, that is called as axle. And then this is going to be suspended to a rigid support as over here, if you can see, okay. There are various ways of suspending it, okay. So I have suspended it like this, and then a string will be passing through this. If I pass the string from here, I made a stand with all what best out of waste. So this is exactly what we have as a pulley, okay. This is your string, inelastic string it should be, and one side we have the hook to suspend the object, and the other side it is moving, okay. So here if you see the other, this is how this is working. Clear? Now there are two ways in which we can use this pulley. One way is to use it as a fixed pulley, as in this case, okay. I hope you are able to see this. This is your fixed pulley. In case of a fixed pulley, the axis of rotation is going to be fixed. So here what we find, that is the frame is going to be fixed. So the frame of the pulley, this is considered to be as a frame. This is going to be fixed. This can be fixed in this way, or it can be fixed depending upon what type of pulley it has or what type of arrangement we require to have. Okay, you might have seen the pulleys in the various applications where, say for example, in cranes we have at the well we have to take out the water from the bucket. Sorry, take out the water from the well using a bucket. Okay. So, and the other is your movable pulley. Okay, this is your movable pulley. I'll show you when we'll come in detail. So first of all, we'll deal with the fixed pulley. of a fixed pulley, if you see, I have got a single pulley being attached, okay? The load is going to be attached to one end. Now here I have made a load, a heavy load I have made so that the things can be seen, okay? You can put anything. So here I have got a hook for this load so that I can attach the load, okay? So here we are trying to fix the load. Now, so this is how, if you try to observe, the string should be passing through the grooves, and now if I pull it, I will be able to lift this load. Clear? So this is the purpose of the pulley.
Physics.
Now in this case, if you observe, this side is your load. Now the load is going to act vertically downward. Okay, the direction of load will be downward. As a result, when the load is acting downward, this string is going to be stressed and it will experience a tension. Okay, if you have, I hope all of you are able to see and listen. So here it will be a tension. So load is going to act downward, tension is going to act upward. Similarly, how this tension is going to act? Now what I am doing is, I am using my effort to pull it down. Okay? So as I am using my effort to pull it down, so the force which I am applying an effort. Now, so the direction of the effort is going to be down, whereas due to my effort, there is a tension in this string, which is going to act upward. Okay? All these things you should keep in mind. We will be using it when we will be doing the derivation for the mechanical advantage and your velocity ratio, and thereby the efficiency. Now, before I start the application of this, I have got a spring balance over here. Although you will not be able to see, this is basically measuring a weight of maximum of 5 kg. Okay. Now through this spring balance, I try to measure the weight of this load, a normal. Clear? Now when I weigh, now you cannot see it in detail because this it's not very visible, but to me it is visible. It's round about 400 grams. Okay. Now this is your 400 grams. So this weight which we are taking, the load which is being taken, that is 400 grams. Now what I am going to do is, I am trying to apply and I will try to see how much load or how much effort I have to apply and what is the result of this. So I am using this spring balance to pull it down. Okay. I am applying the spring balance to pull it down till the load rises. I have to hold it also a little bit. Yes. Now, this is considered to be as an equilibrium position. Equilibrium position means when you have lifted the load from the ground. Quite often you will be understand now. In this case, the equilibrium is not as we are measuring it in the physical balance, or in case of your uh, measuring the torque. Okay, that anti-clockwise is equal to clockwise. Here we don't have that. But simple meaning of equilibrium in this case is that when the load is in air and we are lifting it. Now in this case, if I try to find out, I will observe that the effort which I have to apply, that is round about, if I consider it in new kgf, that is 0.4 kgf. Sorry, approximately. So if I consider the mass as 400 gram force, okay, so the force here which I am applying, a bit more than a 400 gram, okay, slightly more than, not very much, but slightly more than. The reason I will tell you later on, okay. So this is how we are using this single fixed pulley. The single fixed pulley, in case of a single fixed pulley, on calculation, the calculation I will show you later on, but just to note down, we find that in case of a single fixed pulley, the mechanical advantage equal happens to be 1, whereas in the velocity ratio also happens to be 1. Hence, the purpose of a single fixed pulley is to change the direction of application of effort. Okay, this will be more clear when we come to the another part. Okay, so the purpose of a single fixed pulley, this is your single fixed pulley. Okay, the purpose of the single fixed pulley is to change the direction of the point of application of the effort in a convenient direction. So I hope this is clear to all of you. You can just type Y, and if you have any question for the single fixed pulley, because now we will be moving to the single movable pulley. The derivation I will show you later on. I hope the video is clear. Okay, because I want to first show all the demo and then we'll come to that, because the arrangement has to be done that way. Now we come to the movable pulley. In case of a single movable pulley, as per the definition of the movable pulley, we define the movable pulley as when there is change in the axis of rotation, okay, or the frame is in motion, or there is a, now single movable pulley, if I consider, so I'm using it. This will be behaving as a movable pulley for the time being. This is your single movable pulley. In case of a single movable pulley, what you find is that there is a same arrangement of the pulley. The only difference is that in case of a movable pulley, we observe that as we are moving it, so you will find, say if I suspend another object, it's more convenient object for me. Okay, so now if I apply the force, effort, so what will happen? This load is going to be lifted up. But if you try to observe the motion in which the load is going to be lifted up, you will observe it's the entire pulley system which is going to move. So what happened? If I consider that the axis of rotation, if I consider that the axis of rotation at a point is this point, now if I move, so what happens? The axis of rotation is going to change. And because of this change in the axis of rotation, we find that the movable pulley is going to act as a force multiplier. Why force multiplier? I'll just demonstrate it. Now, so what happened in this case? Let me explain you first the direction of the load, effort, and the tension in this. First of all, if you observe this single movable pulley, the lower portion I have a load. The load is in the center of this through the exit. Okay, so the load is attached to the frame. Okay, now this load is being divided into two parts. Okay, this has been balanced by the two parts of the string. This is your fixed part, you can say, which has been attached to the hook. So and this is your free part, okay, for the timing to understand, because this part I can move. This part I can move. Okay, I'm using my sons to help me out in this. So, so this part is a free part, okay, where I can apply the effort. So what happened to the tension in the string? Because of the load, I consider for the time being that the weight of the pulley is negligible. Okay, the detail I'll tell you. So because of the load, there is a tension created in both the strings. Load is acting downward. Here, the load is going to act downward, whereas the tension is going to act in upward direction in both the cases. Now, as the tension is in acting in the upward direction, so this load is going to be divided into two parts. One tension P in this string, one tension P in this string, whose direction will be in upward direction. Clear? Now, here we apply the effort. Say, we are trying to raise it. So I'm applying the effort at this point. Clear? So effort applied is in upward direction. Tension due to this load is in upward direction. Alright? So here what happened? The tension as well as the effort applied both will be in upward direction in this case. Now let us see what it does. I told you beforehand, okay, that this is the force multiplier. Force multiplier, that means I have to apply lesser effort to increase the weight. Okay. So now I will come back to this. I have to do certain adjustment in this. I am using the old weight because we already know that the weight applied is going to take, okay. So the weight of this load, I am using this same old load. The weight of this load is, the weight of this load was 400 gram force. Now I am going to use my this spring balance, okay, to find out this. Now this is, if I consider this as a equilibrium position. Equilibrium position means the load is above the surface, okay. The load is above the surface. Now if I try to see the value, it comes out slightly more than your 200 gram force. So if I consider it as a 200 gram force, okay. So the load was 400 gram force, and now the load is, now effort when we are applying, I am applying only 200 gram force, okay, which means that I am applying lesser effort. And to me also, pulling from this side was more difficult as compared to pulling in this side, because there I am not audible. Okay, so all right, all right. Okay, so now what happens? Here we are applying only 200 gram force to lift the load of 400 gram force. So which means that here this movable pulley, it's only because of movable pulley, because I was using the same load in this case also. But in this case, I have to apply an effort of round about 400 or slightly more than 400 gram force of effort. But here I am applying only 200 gram force of effort, which means that it's acting as a force multiplier. So I hope this is clear to all of you. Now, pulling it in this way, it is a difficult job. Okay, and if I have to lift, say, if somebody has to lift a heavy load, then this becomes more inconvenient. What I have to do now? I have to make it a convenient method. Now, to make it a convenient method, this is acting as a force multiplier. This is acting for change in the direction. So I will use this and this both. Okay. So now what I will do is, wait, I will use another one. This one is a smaller one. I've got another. Look, you'll have to wait a bit till I make the arrangement. Okay. It was small in the previous one. Hold it from here. Every time I have to set this. The grooves are not too deep, and that is why this is creating a bit of problem. Now, this is my arrangement. This is my arrangement in a way that I am using a force multiplier, and then I am also using to change the direction. Now let us try to see if I am using these two pulleys, will it make any difference in terms of the effort? Okay, will the effort be greater? Will the effort be same? Will the effort be less? Okay, let us try to see. So to check this, if you remember, the load was 400-gram force. Okay, earlier, in case of your single movable pulley when we were using, the effort applied was 200-gram force. Now I am using a movable pulley as well as your fixed pulley. Okay, and now let me see whether the effort applied to raise it is same or different. Once again, it has come out of the groove. It's a bit difficult when the load is more, but to show you the difference, I have to have the greater load because this count of this is 100 gram. Now, here when I apply and try to observe, I find it to be slightly more than 200 gram, or in other words we can say that this is only 200-gram force. Okay, which means that if I am using a single movable pulley along with a fixed pulley, it is not going to change the nature of the single movable pulley. The single movable pulley will be acting as a force multiplier. This is only being used to change the direction for a convenient, so that I can apply the force in the convenient direction. Okay, which means that the this arrangement where I am using a single movable pulley as well as a fixed pulley, I am able to only change the direction. The mechanical advantage will remain same, that is equivalent to the movable pulley. So this arrangement will be equivalent to your movable pulley, okay, and its mechanical advantage will be equal to the mechanical advantage of single movable pulley, and velocity ratio will also be equal to single movable pulley. Okay, so I hope this is clear to all of you. This was your demonstration part. Here also, if you try to observe tension in these two, load over here and now effort over here. Clear? But when we are calculating, we will be calculating in terms of only the movable pulley as we used to. So what happened? We consider that this effort is also being applied for calculation point of view. Effort is applied from this side, and therefore the tension is in this direction. The tension is in this direction. Tension is basically being created due to the load. Now, every time when I was pulling, I was telling you that okay, this is equivalent to this. Okay, earlier single fixed pulley, I was telling that it was equivalent to your load was 400, and in case of single fixed pulley, the load was equivalent to 400 gram force. Effort applied was 400 gram force. Okay, in single movable pulley, the load was 400 gram force, effort applied was 200 gram force. And in both the cases, I told that the effort is slightly more than 400 gram force in single fixed pulley and 200 gram force in single movable pulley. Okay, so as a result, why this word slightly more? Slightly more because we all know that we don't have a perfect system. Okay, we don't have a perfect system, uh, and there is a loss of energy. So there is also a loss of energy in this case, and so we have to apply the effort slightly more than what actually it should be. So if it is 200 gram force, I was able to see there is a slightly more than 200 gram force. If it was 400 gram force, it was slightly more than 400 gram. Now this was about your moving and your fixed, single fixed pulley. Okay, now we will be coming to the derivation part. Okay, the demo part is nearly over. Uh, the next portion will be your block and tackle system, and please don't just start leaving. I'm continuing with the things. Okay, so block and tackle system, and then we have the Archimedean system. Okay, I'm afraid I may not be able to show you the demo of those, okay, because of the constraints, but I will be trying to explain those things. Okay, now for the time being, I'm just trying to come back to the by replacing my apparatus over here. Okay, you be in contact. I'm just switching off my video, and then we will come to the writing part, that is your derivation of the mechanical advantage and other thing. Let me explain you the derivation part, and then we will be coming. I'm going through your chats at present so that I can answer your queries before I start with the writing part. Function of pulley. Function of pulley is basically it has been used mainly for two major purpose. One is your force multiplier, and the other is your to change the direction of application of effort. I hope Tushar Mishra, it is clear. When the load, Mayank, when the load is been suspended down, the reaction in the string is in the form of tension. Therefore, the load is equal to tension. Now, in case of your single fixed pulley, it is equivalent to the tension. Whereas, in case of your movable pulley, it is equal, the load is been divided into two part of the string, and therefore each string is experiencing a tension T. Okay, so the load will be equal to your the sum of these two, or you can say that the load is half, and that is how we are reducing the effort. I'll come to that portion. It's not one pulley. Here up, uh, it is not one pulley. It's basically whether we are using the movable pulley or we are using the fixed pulley. Yes, effort becomes T by 2. Mayank, what tension does not remain means what? It's not very clear what. Uh, Single fixed pulley, if it has no gain in the mechanical advantage, but quite often it is required that if we are able to apply the effort in the convenient direction, okay, that is also very much required. Okay, just like pulling water out of the well using a bucket. If you are standing at the edge and trying to pull it vertically up, so applying a force upward is a bit difficult. But if you are using a pulley, you can apply the force horizontally, and that is more convenient. Similarly, in case of crane and other things. Okay, so that is how we are using it. No, that won't be happening because the load is going to be fixed. Once you suspend the load, it is going to be fixed. So according to the load, it will have a normal reaction. You might have studied the force of action and reaction. Okay, so this force of reaction of the uh, load is basically been divided, is been given to the string. Okay, now in a string, when we are applying a force, we call it as a tension. So therefore we are using the term tension. I hope this is clear. Okay, let me come to the derivation part, and then we'll come to the chat. So we were dealing with the pulleys. I just go through the summary. We have pulley, okay. So pulley basically is a group. You have seen that there are two ways in which we can use pulleys. Okay, one is either we fix it, and the other is we use it as a movable pulley. Okay, so now here it's very important to have a friction between the groove and the, that is the rim part, and the string. So the string which is passing over the pulley, okay, there we require to have certain friction. Otherwise, the disc is not going to rotate. The wheel is not going. The pulley is not going to rotate if it has got no friction. Now, the loss of energy is taking place basically if there is a friction between at the axle. That is the point where it is rotating. Okay, it is fixed. Clear? Axle means this point. Okay, so here if I have, say, I'm using an axle over here, axis and about which this pulley is going to rotate. Now here if I am having friction, then my energy which has been utilized, my input energy, some part of that input energy, some part of that input work will be utilized to overcome. Okay, and that is why when we were trying to pull and we were saying that slightly more than 400 gram force, slightly more than 200 gram force, okay, it is because of this, because it is not a frictionless surface. Okay, another thing is that the string should be massless. Okay, now we come to the single fixed pulley. So in case of a single fixed pulley, what we have a load on one side, effort applied on the other side. Okay, now because of this load, we have a tension in one part, and because of this effort, we have the tension in the other part. So if I neglect the friction and the mass of the string, the friction at the axle and the mass of the string, then for ideal pulley in a balanced condition, in a balance, that is in the equilibrium condition, I have shown you the equilibrium condition, that is when the weight is not under any support, it is in air. Okay, so for ideal pulley, you all are aware of the term ideal. What we mean, we know that the load is equal to tension and effort is also equal to tension, as you can see in the diagram. So mechanical advantage, if I have calculate, so mechanical advantage is load by effort, and therefore this becomes T by P equal to 1. And that is why, since the mechanical advantage is equal to 1, that is why we say that this is a pulley, or this is a machine which is used to change the direction of the effort applied, or it has basically been applied to. Okay, now let us try to derive the formula for velocity ratio. Now we all know that if I pull this, say, by a distance d, that is dE is equal to d. This is going to raise by the distance d, that is dl will be equal to d. Clear? So here the distance moved by the effort, that is d, distance moved by the load in upward direction, effort will be moving in downward direction, load will be moving in upward direction, that is also d. Okay, so velocity ratio, this is dE by dl. As a result, we get it as E by d equal to 1. Now we have mechanical advantage equal to 1, velocity ratio equal to 1, and so efficiency will be your mechanical advantage by velocity ratio, this is equal to 1. Okay, so for ideal pulley, keep in mind the term, the derivation which we have done it for the ideal pulley. Okay, ideal pulley means there is no mass in the string and the friction at the axle is negligible. Okay, so for ideal pulley, the mechanical advantage will be 1, velocity ratio 1, and efficiency is 1. But actually, when we are applying or when we are practically doing, so for the practical single fixed pulley, what we will have? Practical or actual? Actual pulley. We will have mechanical advantage slightly less than 1. Velocity ratio will remain same. This I had explained to some of you who had asked, okay, why velocity ratio is going to be 1, and if still there is a problem, I'll send them to ask it in the group, I'll explain. Okay, then efficiency is going to be less than 1. Alright, now this is all taking place because of the friction at axle, that is the axis of rotation, okay, or if you are using the mass of string. String is not massless, and therefore some effort is being utilized over there. As a result, what will happen? Effort what actually we are applying, that is slightly more than the practical effort. Okay, I'll not write greater than 1. I should write down effort applied is slightly more. Okay, slightly means a little bit more than the actual effort applied, what should be applied. So I hope single fixed pulley is clear to all of you. I'm going to the chat part so that if you have a problem, is going to be 1. Ideal is never possible. Anshika, it is not possible to have a massless string, and that is why we have to apply a effort bit more, and that is why there is a loss of energy. There is a concept of loss of energy. There is energy dissipation. Okay. Alokik, we are basically using both the type of pulleys, the fixed pulley and the movable pulleys. Okay, towards the lower end, and in fact, we are not only using a fixed and movable pulley, we are using a sort of lock and tackle system or Archimedean system. Okay. Now we move to the next question. That is mechanical advantage for the movable pulley. So movable pulley, single movable pulley. Okay. In case of a single movable pulley, as you remember, load is been suspended here. Tension, this will be on one side, that is on the hook, and the other side is tension. So here the load has been divided into 2 parts. Effort okay, if we try to calculate the mechanical advantage, so for ideal pulley, which means that I'm not considering, I'm neglecting the friction at the axle, I'm neglecting the string, the mass of the string. So what we find, load we can write it as load is going to be balanced by both the T, that is T plus T equal to 2T. Okay, and effort, if you observe, effort is going to be balanced by the tension on the effort arm. Okay, that is the effort side of the string. Hence the mechanical advantage, if you try to find out, this is load by effort is equal to 2T by T is equal to 2. So what you find mechanical advantage? You find that mechanical advantage is greater than 2. Sorry, is equal to 2 greater than 1. Now, if the mechanical advantage is more than 1, the machine is going to act as a force multiplier. And as the machine act as a force multiplier, so here we have seen that the single movable pulley is acting as a force multiplier. So it has basically been used to lift heavy load. Okay. Now let us try to see the velocity ratio. Try to calculate the velocity ratio. Now here I'm using the red one, or I use the white one. Now when the effort is applied and suppose effort is moved by the distance, say if effort is moved by the distance say d. Now this much movement of the distance, that is dE is equal to d. Then we consider that the distance moved by the load. Okay, so this will be moving by distance d. The load is going to move by the distance d by 2. Because if I consider that this entire portion is going to be from here moves to here, this portion basically, for a movement from this point to this point, the entire of this rope is going to move to this portion. But if you observe from here, when it moves to the other portion, this, okay, this is the total length of the rope which is moving, and therefore this will be only the half of the length, and as a result this will be moving the uh, so the pulley will be moving by the distance d by 2. Okay, that means the load is going to move by the distance d by 2. Once again I will try to explain you. Let me first derive it. So velocity ratio, if you try to find out, this is dE by dL. This will be equal to d upon d by 2 equal to. So in case of your single movable pulley, we find that the velocity ratio is equal to 2. Mechanical advantage equal to 2. So efficiency, this will be your mechanical advantage by velocity ratio, that will also equal to 1 for ideal case. Which means that actually the mechanical advantage is going to be slightly less than 2. And this is again because of the reason that we are going to have the loss of energy or loss of the work done due to the friction at the axle and the weight of in this case it will be the weight of the pulley also. That is, the effort applied is slightly more than the L by 2. Okay, which means that the cause for this is friction. I'll be sending the notes. You can note down, and most probably axle, and here weight of pulley, because pulley also has got weight, which is also going to be affecting. Mine was less because I was using a plastic pulley, okay, made up of hard plastic. So so the weight was very less, and that is why the variation of the string which I was using, that was also having very less mass. I will not say that it was negligible. Therefore, the variation in the uh, effort applied was not too much. Okay, it was even less than 50 gram force. Okay, it was slightly more than your 200 gram force when I was using the movable pulley. Okay, so I hope this is clear to all of you. Uh, here are first. Okay. Here it's basically in case of single fixed pulley, if you observe the when you are pulling the rope down, okay, in a single fixed pulley, so the pulling of the rope is basically creating the way the load and the effort is being applied in the fixed pulley and the movable pulley is entirely different, and accordingly your tension is going to be varying. Okay, so in case of single fixed pulley, when we are applying the low effort, we are applying it in the downward direction, and therefore the tension was because of the uh, effort which we are applying, and hence it was equal to this. Now, in movable pulley, we are applying the effort in upward direction. Tension is because of the load in this case in both the arms. So load was equal to T plus T both. But when we are pulling the string from one side, so we are applying the force which was equal to the tension in the one arm, and that is why E was equal to T. The efficiency of any machine, you know that why it is not. In case of pulley, it is not 100% because it has got friction at the axle point. Axle point is that where it rotates, and that is why we use ball bearing and other means to reduce that friction. Okay. Secondly, the weight of the pulley and the weight of the string. These are basically causing the deficiency. See, by now the class is nearly over because time is up. Somebody will end it abruptly. Okay, so let us try to ask whatever problem you have in the group. I'll put these things into the group also. Okay, maybe tomorrow on my next class I will be starting with the next question. Okay, so bye for now.